Hey guys, today we're looking at 8.5 Day 1's notes, which is all about graphing quadratic equations in intercepts form. Now before we hop into what intercept form looks like, we're just going to do just a little bit of warm-up review of factoring and solving that we did back in Chapter 7, because that's going to be important for us moving forward. So in box 1 here, we're asked first to solve this equation. And remember back in Chapter 7, 7.8, we looked at how to solve an equation with factoring, where if we have everything over on one side set equal to 0, we're going to go ahead and factor out that left side. So in this case, x squared plus 6x minus 40 should factor out into, what is it, x plus 10 and x minus 4 equals 0, right? Because negative 4 times 10 is negative 40. 10 minus 4 is 6, so that's how we would factor that out. And then from here, we would set each of these factors equal to 0. X plus 10 equals 0. X minus 4 equals 0. We subtract 10 on both sides to get negative 10. We add 4 on both sides to get positive 4. And those are my two solutions. That would be solved completely. Now, I do a very similar thing if I'm trying to find my x-intercepts of an equation. In this case, they want us to find the x-intercepts of y equals x squared minus 6x plus 5. Now remember, on a graph, and I'm going to find a little graph here just to reference, I'm looking for my x-intercept, which is any of the points along this x-axis. What makes all of those similar is that they all have the exact same y value, which is 0. If I'm trying to find an x-intercept, I can let y be 0 and then solve for x. Just like I did back when we were working with linear equations, when we were trying to find our y-intercept, we let x be 0 and then solve for y. So we can do the same thing here. Our first step for finding the x-intercepts of an equation, we're going to replace my y value with 0, which gives me 0 equals x squared minus 6x plus 5. And now we have an equation very similar to the one we just did up above. I can go ahead and factor out my right side here. We're trying to look for the two things that multiply together to give me positive 5 but add up to a negative 6. So in this case, the only combination that works there is if it's negative 1 and negative 5, because negative 1 times negative 5 is positive 5, but negative 1 plus negative 5 is negative 6. So then from here, x minus 1 equals 0, x minus 5 equals 0. I can then add 1 to give me an x value of 1. I can add 5 to give me an x value of 5. And those are my two solutions. Now what that tells me is that my x-intercepts are 1, 0 and 5, 0, because both of those we let the y value be 0 and we were solving for x. So those would be my two x-intercepts for that graph. Now that is what we're going to be doing for intercepts form. Intercepts form is going to start for us already factored out. But what we should realize is that once we have it factored out, because our x-intercepts are always just set equal to 0, because our y value is 0, it's basically just doing zero product property, ZPP, on those factors to figure out what my x-intercepts are. Now, I have it here written up in the new format for us, y equals a, parenthesis x minus m, parenthesis x minus n, and here m and n, the two things that are subtracted from my x value inside those parentheses, are the x-intercepts. Just like we saw here in this warm-up problem we just finished, once it was factored out, x minus 1 and x minus 5 were my two factors, and we saw that positive 1 and positive 5 were my two x-intercepts. So whether you want to think about it in terms of setting each parenthesis equal to 0, like we did back in Chapter 7, or you just like thinking about it in terms of the opposite of what I see inside the parenthesis are my x-intercepts, that's fine. However you want to make it work in your brain, go with that. Now obviously that gives us our x-intercepts, but we know we have to have my vertex and my AOS in order to be able to graph this equation. We need to know where that point is of my parabola before I can go ahead and graph the rest of it. Now, I have two different options on how to do this. I do have the formula written here for how we can figure out my AOS, which is just adding my two intercepts together and then dividing by 2, finding their average. That tells me the x value for my AOS, so then you could just plug it back in to find the y value for your vertex. The other way that we can do it, and I'll show you when we get to the graph, is just looking at it more visually, not having to use a strict formula for finding the AOS, but we can do it using the graph, and I'll show you how to do that. But for right now, for this first one, they want us to find the x-intercepts and the vertex of y equals x minus 4, x minus 10. So without having to do any extra work, we should be able to figure out that my x-intercepts are 4, 0, and 10, 0. Those are my two x values that were subtracted from x in my equation. Those are my two, my m and my n, basically. So 4, 0 and 10, 0 are my two x-intercepts. Now to find the vertex, we're going to do that in red. So if you're going to use the formula, if you don't have to graph it, and this is all you're asked to do, we're just going to add up m and n, and then divide by 2. So 4 plus 10 is 14, divided by 2 is 7. So that tells me my AOS is 7. The x value of my vertex is 7. So what I have to do then to find the y value of my vertex would be plugging that x value in. So if my equation is y equals x minus 4 times x minus 10, I end up with 3 times negative 3. Right, 7 minus 4 is 3, 7 minus 10 is negative 3. So I have a y value of negative 9. So my vertex is 7, negative 9. So that's option 1. If you like the formula, it'll be given to you. Again, that's going to be on your cheat sheet that you guys will have for Chapter 8. But if you don't like that, I'll also show you a way to do it. I think it's a little bit more intuitive. Just personally, I'd rather not use a formula if I have to graph it anyway. So I'll show you how to do that for boxes 3 and 4. So here, instructions, straightforward. Graph the equation, graph the function. Now, I have to be careful because my intercepts are always what was subtracted from x in my equation. So in each of these parentheses, negative 3 and positive 1 are the two things that are subtracted from x. Just like we saw with vertex form in 8.4, the inside of my parenthesis is always opposite of what it is. So if I see m plus 3, negative 3 is that x-intercept. In this case, x minus 1, we see negative 1. Positive 1 is actually that x-intercept. So I'm going to start with those. I know we usually like starting with my vertex, but since I know those 2 points, those are my two x-intercepts, so I'm going to go ahead and plot those first. So we got negative 3 and positive 1. Those are my two intercepts. Now, this is the other option. If you want to find your vertex just using the graph, we know that in a graph, in a parabola, any 2 points that have the same y value have to be the same distance from your AOS from each other, meaning your AOS has to split the middle of any 2 points that are at the same y value. And my two x-intercepts here have the same y value of 0, which means my AOS has to be halfway between those two. Since there are 4 units between negative 3 and positive 1, that means halfway between the two would be 2 units from either side. So without having to use my formula to figure it out, I know that my AOS happens at negative 1. Negative 1 is the halfway point between my two x-intercepts. So I don't have to use the formula for that. I do still need to use it to figure out the y value of my vertex. I didn't know what the height is. I don't know where that happens. So in this case, I still have to plug in a negative 1 into my equation. So y equals negative 1 plus 3 times negative 1 minus 1. So that gives me, 2 times negative 2, which would be negative 4 for the y value. So I know that my vertex is negative 1, negative 4. So we can go ahead and plot that point. Negative 1, negative 4. I don't have anything out in front of my parentheses meaning my a value is just 1, so I still follow my regular 1, 3, 5 shortcut. So from my vertex, I go up 1 over 1 on both sides, up 1, 2, 3 over 1, which those are already plotted, which is good. That means it matches my pattern. It means I've done something correctly here, because up 3 over 1 would be my 2 x-intercepts that are already there. So I've got my 5 points, I've got the bare minimum, connect it with a nice smooth curve, and we get to call it a day. That's not a very nice curve on the left side, right side. That's still not bad, but okay. So there we go. That is graphing in intercepts form. We'll do another practice problem over here in box 4, but that's pretty much it. So in box 4, we've got negative parenthesis x minus or x plus 1, x minus 5. So once again, my m value is a negative now because I see it as plus 1, so it's a negative 1. And then my n, which doesn't really matter which one you call which. It's not important which one is m and which one is n. But those are my 2 x-intercepts, negative 1 and positive 5. So I go ahead and plot those 2 points, negative 1, positive 5. If you want to use your formula, go for it. Negative 1 plus 5 is 4, divided by 2 is 2. Otherwise, again, you can look at it just visually. Negative 1 and 5 are 6 units apart, so 3 from either side would be the middle, which happens at positive 2. So then, to figure out the y value of my vertex, I'm just going to plug in positive 2 into my equation. Y equals negative 2 plus 1 times 2 minus 5. So negative 3 times negative 3. So we get a y value of positive 9. So we got 2 negatives there. 3 times 3 is 9. So all the way up there is my vertex. Which makes sense because looking at where my vertex happens relative to my 2 intercepts, it's going to be a downward facing parabola, which should happen because we can see here my a value has a negative out in front. So my a value in this case would be negative 1. So instead of my regular up 1 over 1, up 3 over 1, up 5 over 1, we're going down instead. So now from my vertex, down 1 over 1 on both sides, down 1, 2, 3 over 1, and then this next one should be 1, 2, 3, 4, 5 over 1. Yep, those are my points. There we go. And then connect it with a nice smooth curve. There we go. And there is my graph for box 4. That is graphing with intercept form. Your homework for tonight is down there at the bottom, page 455, 3 through 12 all, both evens and odds. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.